Hi all, hope you're all fine. And in this session, we are going to learn about normalization. The normalization concept in database is very important, as you all know, and it is one of the major concepts which help the databases to be intact. Eliminating the redundancy, the inconsistencies, and it helps to maintain the data integrity in the database systems. So that is what we are going to see in this particular video. Let's move on. So what is normalization? So basically, normalization is the process of evaluating and correcting tables. Yes, because when we start working or when we start designing the database tables, we create tables and we try to come out with the various entities according to the scenario. We try to find out the keys and we try to come out with the physical model of the table. So all these things are basically possible. But when we try with the relationships, there will be a lot of inconsistencies and redundancies which will be there as anomalies. I mean, like, say we can have some redundant data in the table, or say if one of the record is deleted, it may affect some other table, right? And if you're updating any information that is not consistent with the other information which is already there, or it is not being updated properly, so or you have to go and search for multiple locations to make sure that the database is consistent and the data integrity is maintained. So such kind of anomalies can occur based on the insertion, deletion and updation of the data in the database. So this may create redundancies and inconsistencies or data integrity issues in the table. So we need to minimize that. So can we do that with an easier way? Yes, we can do that with the help of normalization. So for reducing the data redundancies and inconsistencies and to maintain the data integrity in the database due to the data anomalies which we have, so for that we have a technique called normalization in place. And how are we going to do all this? Yes, we do have different normal forms for making sure that the data is normalized. Okay, so the data in the database could be normalized by following this normal forms. Like, we could make sure that the data is in the first normal form, then the data is in the second normal form, the third normal form, the Boyce Codd normal form. So these are the various kind of and we have joint normal form. There are different type of normal forms which are available, multi-valued, right? So these are different type of normal forms which are available. If we can make sure that the data is basically is normalized, then we could say that it is basically the complete data in the database is normalized. So let's see in detail, and let's clear this vagueness which is there in our mind. So let's take this example. Say you're given with employee ID, the name, department, and student group, right? So when you closely observe this particular data, and you could see that this brush, I don't know what to pronounce it, but still, he is actually part of the CIS department, and the student group is technology organization and beta psi. So this is what it is basically, there. So there are actually two different, the employee IDs are different. So hoping that these two airbrush are basically two different people, but they are part of the same organization and but different student groups. Okay, so this is kind of a there could be such kind of anomalies which are there, which is confusing for you whether it is the same person or different person. So such kind of anomalies may occur. So an update anomaly, say if you are actually trying to update the data in such a way that I'm just updating, so I'm just giving a query in such a way that update the department of a brush, then what happens is that update the student group or department. Okay, then what happens is that if they are two different people, then definitely the data of one of the people will be updated in the wrong sense. So there could be some update anomalies which are happening. Then say just imagine that we are going to delete this beta alpha phi psi department. Then another anomaly which will happen is that, when we delete this, okay, we don't know whether, this J long fellow is basically part of this one, or it's actually, a different company or not, or whatever it is. So if the student group beta alpha phi disbanded, was deleted, and J fellow and the accounting department would cease to exist, right? So this is another issue which will happen. um, I mean, like, we don't know whether they are actually, part of it, or to be deleted or not. So such kind of anomalies can then, say, just imagine that, we are trying to include something. I mean, like, say, a person is basically inserted into the table, but the student group is not defined, or he is not part of any group. So it's kind of, we don't know which group he will be, in which student group he will be into. So such kind of inconsistencies could be there. So when you look at this, say if you're deleting one particular thing, or if you're updating, or if you're inserting something, all this can cause data anomalies. So you can have update anomalies, you can have delete anomalies, you can have insert anomalies. So all this will create inconsistencies or redundant data, or data integrity issues which can happen in the whole database. So in order to avoid these, we comes up with this we come up with this operation called, the process called normalization. So normalization is basically the process of, what we do is that the relations means it is nothing but the entities. Say if we have an entity, this is your entity, right? So this is one particular table, or an entity, or a relation. So we split this relation, or this entities, into well structured smaller relations, so that we don't have any inconsistencies, or inconsistencies in the database anymore. So that is what we are planning to do. So we basically split the table. Okay, we split the table, and we give the primary keys in such a way that, we do have a final structure of the database, maybe a smaller versions, or a divided version of the table, where there are no inconsistencies there in the table. Now moving over to the next one. One second. Say, yeah. Now we need to, before moving over to what normalization is, it is very important for us to understand certain terminologies. So the first one in the queue is functional dependency. What do you mean by functional dependency? This is kind of the definitions which we have to follow in any of the textbooks, if I could see. So functional dependencies are basically used in the design of relational database. Okay, and why are we using that? We are using it to eliminate the redundancy or the data duplication, and it will reduce the possibility of update anomalies. So redundancy is eliminated through normalization. We already know that. So if a database schema is properly normalized, then all columns should be functionally dependent on the table's primary key. So all columns should be functionally dependent on table's primary key. So let's understand it with the help of an example. So before going that, yeah, how is it actually represented? Yes, so X is functionally dependent on Y. X is an attribute or a feature or a column in your entity, and Y could be another column or attribute, or attribute in your table or a relation. Okay, so Y is set of attributes. This Y could be a single attribute or a set of attributes. Okay, and X is actually an attribute or a set of attribute, because sometimes your primary key could be a composite key also, right? And these are your non-key attributes. Okay, so this is basically called as X is functionally dependent on Y, or X determines Y, or you could say that Y is functionally dependent or determined by X. Okay, and you cannot say that the reverse is true. So if you have something like X is functionally dependent on Y, that doesn't mean that its converse is true. Okay, just keep that in mind. Say we will see an example now to just make it clear the air. So we do have the student ID and course. Say, so these are the primary key. So this is a composite key where you use both the student ID and the course together as a composite key. And both of them are basically, so this is a primary key. So this primary key is basically helping us to determine the grade. Say I have the student ID 1 and who is Ahmed and has got a grade A. So it is very important. So Ahmed, for the course DB1, he got grade A. Okay, and 1 with the course, say the student ID 1, say student ID 1 is Ahmed. Okay, 1 with the course CP2 got the grade B plus. Okay, so now you could relate to a real-time scenario that if you have the student ID and if you know the course, it is very easily we can actually define the grade, and it is easy for us to understand what is a grade of a particular student for a particular course. Okay, so we could say that the student ID and the course determines the grade, or you could say that the grade is functionally dependent on student ID and course. Okay, grade, but can I write grade functionally dependent on student ID and course? No, it is not true, because if I simply give A is functionally dependent on student ID course, it could be any student, any course, so multiple A's comes in the picture, which is not true. So that's why we are saying like the converse may not be true. Okay, so other students may also have A in the same courses. It simply means that a particular student in a particular course has one and only one grade. That is the meaning of this. Okay, a particular student and a particular course has only one and only one grade. Okay, but one grade may be related with multiple students, so we cannot say that, right? So the converse might not be true. Now moving over to the functional dependency. So functional dependency, so to just make it easier for you, you could just think as if it is a constraint which is applied upon the attributes of your entity. Say you have an entity or a relation or a table, say student table or a student relation or a student entity, then you could say that it is some rules which are enforced upon the attributes in your table. Right, so the value of one set of attributes depends on the value of another set of attributes. That is nothing but functional dependency. So let's say this, let's take this example. Say we have student ID, course, department, last name, first name, instructor, grade, etc. So in this one, so I'm just taking like this last name and the course. So I'm taking SNORD and CP365 implies the grade. Okay, so implies grade. Say if I take SNORD 3 CP363, okay, F and SNORD and CP4 400 is A minus SNORD, and this one is C, and here you have another SNORD and CP102, it is A plus. Is this relation is true or false? That is my question. So this is basically this does not determine this grade. Why? Because you cannot take last name as along with, because you have a SNORD here with CP102, okay, and here you have another SNORD with CP102. But if you look at the first name, so if you it is basically this is SNORD Cranston and this is SNORD Lilabelle, right? So these are basically two different people, so which can cause some confusions onto the data which you are actually providing. So you could say that this does not hold, or this is false. So this functional dependency is false because there are multiple occurrences of the combination of the same last name and the course name, where you already know that its own first name are basically different, so they are two different people. So this can cause confusions, and so we could say that say if I'm giving you one particular functional dependency and asking you whether it is true or false, you could say that this is false. Now another example which is given to you is that, say the same thing, okay, so you're given with the student ID and giving the last name and the first name. So you have the student ID which gives the SNORD Cranston, and say this student ID will give you SNORD Lilabelle, right? So this can clearly give you a table which clearly identifies the person with the last name and the first name, right? So this this is particularly so you will get basically a table with this one with SNORD Cranston, then this one with Zachary, and this one with SNORD Lilabelle, right? So this is how it is. So it would be a perfect table, so we'll not have any issue. So this is true. So the student ID is functionally dependent on last name and first name, and which is a true statement. And now comes another one as instructor and followed by the course. So say if I look at the instructor, D Brown is CP365, D Brown is CP102, then D Brown is CP102, then D Brown is this one. So but here if you see, so this basically is false, because one instructor is basically involved in many courses. So it is you cannot say that there is a multi-valued there is a multi-valued attribute which comes in the picture. So D Brown, which is actually having both CP3 and 2, so it's a multi-valued attribute. So it is not it is not basically one which you could say that it is clearly dependent upon the other one. Okay, there are multiple values on that. Right, so this is how you will identify whether a particular functional dependency is true or false. So you need to basically consider a functional dependency which is true. So now moving over to the normalization. So the process of data normalization will make sure that the database design is free of any problems that could lead to the loss of data integrity. So for that we do have first normal form, second normal form, third normal form as part of this course. And if you want to go further, you have Boyce Codd Normal form and join normal form. So there are different type of options which are available for you, but we will concentrate on first normal form. How to say, if you are given with a table which has got some anomalies, you need to identify those anomalies and you have to make the table into the first normal form. Then you need to curate your table to second normal form. Then you need to curate your table to third normal form. But in each of the normal forms, you need to consider certain things. So let's see what they are. So these are basically the steps in the normal form. So you have fourth normal form, fifth normal form, it just goes like that. And say if you look at a table, so initially you'll be given with a particular table. Sometimes the table will have multi-valued attributes. Okay, so if you have a table with multi-valued attributes, then you need to convert that particular table into a first normal form. Then you need to convert that table into a second normal form. Then you have to convert the table into third normal form as part of this course. And if you are learning an advanced DB, then you can change them into BCNF form and 4NF, 5NF. It goes like that. Okay, and now so the major steps involved is you will be given with an unnormalized table, or the table which is given to you will be unnormalized. So you have to first normalize it into first normal form, then second normal form, then third normal form. So what do you mean by what would be there in the first normal form? I mean, like unnormalized form. So you'll be given with an entity. So you have to create an entity and you have to give it a name. Then you are listing all the attributes, you are identifying the primary key, right? And then you need to identify the repeating data which has one entity. Okay, so that is what we are going to see in the unnormalized form. So in the first normal form, let's see. So in the first normal form, basically what we are going to do is that we are converting from the unnormalized normal form to the first normal form. Okay, so what are we going to do? So in the first normal form, we are trying to eliminate, or to identify the multi-valued attributes, and we are going to remove that. We are just going to make sure that there are no multi-valued attributes. Okay, so from the unnormalized normal form, you need to identify the repeating group. Okay, and then give it an entity name. Then you have to identify the primary key. Then you need to take the key from the first table to link it with the two entities, then label it as, because whenever there are two different tables and if you are trying to relate to each other, then you require a foreign key there, and then you are actually coming up with a composite key. So whenever you do have a MS2N relationship or multi-valued attributes, you know that you are going to form a composite entity and you are going to put the primary key from the other tables, right? So it is something similar to that, but not exactly, a little bit of variations. So that's what we are going to see here in this thing. So let's take this example. So we are given with one particular table with student, age, and subject. And when you look at this particular table, you could see that the subject column has got multi-valued. It is actually multi-valued attribute. What do you mean by multi-valued attribute? If a cell can have multiple values, then they are called as a multi-valued attribute. So subject is basically a multi-valued attribute. And now coming back to what do we do in the first normal form? Yes, none of the columns, so either student or age or subject in the table should have multiple values in the same row. So it's not possible. So now what you have to do is that if you have multi-valued attributes, you need to split the table, split the relation, or split the entity into a table which does not have multiple values. So what could we do? Yes, we have Adam, age, biology here, biology and max. We are splitting this into two different records. So Adam 15 biology, Adam 15 max, and Alex 14 max, and Stuart 17 max. So we are splitting the table so that into multiple rows, so that we get this particular table, right? So this is what we are, it's as simple as that. This is our first NF. Okay, so just imagine, consider this particular example. So you have S, B, C, T, F, and blah, blah, blah is given to you. And in this particular information, okay, the FANG is basically registered for two courses. Right, he is actually registered for two courses, so he has DB and CS, and he has got two different tutors, and all these informations are available, right? So how can we actually split your table? So you could say that FANG 1919 DB ZVI1, then FANG see here FANG 19 and so OS LN 2, like that you can split. Say if you how will you split this particular table? Yes, John 1980 OS Allen 2 and John 1980 PL Marsha 4. So you are actually splitting this multi-valued attributes into separate tables, so that you don't have any like in one particular cell you don't have multiple values which are coming in. So this is one way where you could convert your multi-valued attributes into multiple, so separate records. So now this is another example. So here they have simply given you the schema, and with they have also showed you about the functional dependencies. So I will tell you how you can actually read the multiple the functional dependencies. Say the functional dependencies, this arrows means it is actually like say the D number functionally dependent on D name. Okay, D number functionally dependent on D manager SSN. D number functionally dependent on D location. So there are basically three different you can actually see that there are three different functional dependencies which are given to you. Okay, so that means that you can actually split this into three different tables. That's the meaning of it, that you will get to know later. But just imagine, say this is the data which is actually given to you. So this is the schema, and this is the data which is given to you. Okay, so in your data, basically say you are given with D name, D number, and everything. So you know that in a relational model, if a particular attribute is underlined, then that is a primary key. Right, so you're given with this. So now what you have to do, say there is one particular attribute with multiple values. So that's why it is basically, you could see that in this functional dependency, this is actually dashed lines. So this dashed lines shows that D number functionally dependent on D locations, but D location is a multi-valued attribute. That is the meaning of it. So D number is associated with D locations, but D locations is a multi-valued attribute. That is the meaning of it. Okay, so now how can you actually make it into one normal form? In the first normal form, it is very simple. So you will keep it as research 5 blah 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 Bellary, research 5 this number, and Sugarland, research 5 this number, and Houston, right? So you will divide this particular multi-valued attributes into three separate records, followed by the rest of the records you will add. If there is any other multi-valued attributes, you would have divided that also. This is nothing but now here the table is in 1NF. Okay, hope you are with me and able to understand and follow me. So this is as simple as that. So just to recap on how you can actually do that. So remove the repeating group into a new entity, give the new entity a name, and identify the primary key for the table. Take the key from the first table with you and link it to the entities. So this you will be able to see when you will be able to exactly follow this when you do it at the end. We will try to understand the examples. Okay, this is now we are trying to understand what are we going to do in the first normal form. So in the first normal form, if there is any multi-valued attributes, you will separate that into multiple entities. Okay, like multiple records. That's what you're going to see. So now this is again another example, like you're given with one particular table which has got shirt ID, design, and size, right? So here when you look at this particular table, here the primary key is basically the shirt ID. Okay, so what you could do is that you can actually divide your table into 100 Mickey Mouse XXL, 100 Mickey Mouse XL, 100 Mickey Mouse M, and then 101 flowers M. Like that you can actually divide your table into two different entities. Okay, so this is what basically you could do. So now in order to understand what we have basically told here, what you could also do is that you can actually uh, what you will do is that you have actually taken this 100 XXL 100 XL like that, and you can actually keep this design also this way. We will try to understand this. Basically it is also in the 2NF form. That's why this we will learn in the next step. Okay, so just understand that you can actually divide this into 100 Mickey Mouse XXL, 100 Mickey Mouse XL M etc. into three different forms. So this is how we could basically do it. So now in this particular example, you have got say SSN ename. Okay, so this is your structure which is given to you. So SSN ename, P number, project. So here you have projects which has got P number and hours. So what you could do is that you are taking the SSN. Okay, so when you look at the table, see here, remove the repeating group into a new entity, give the new entity a name. Okay, so here this is what it is. So here you know that this P number and hours are basically repeating. So you're actually taking into P numbers and hours. Now what are you doing? And give the new entity a name. Just imagine that you're giving the name it as like EMP project 2, and identify the primary key for the table. Okay, so for this particular, say you have this P number and hour, so you identified P number as your primary key. Now what is the next one? Take the key from the first table with you to link the two entities. Okay, so just to link with the rest of the table, you have actually this SSN number and you are adding it here, and this is basically your foreign key now, foreign key to this particular table. Now you have composite key. That means that now these two together has to identify this, right? So SSN and P number together has to identify, because you need this one and this 2. So this one, this 2 and 7.5, like that you have to make. So these two will become a composite entity now. So this multi-valued attributes, you can actually split them into a composite entity. Now say if you look at this particular example, then this ename is there, that you can actually keep it separately. So SSN and ename with the SSN as its primary key. So keeping this in mind, if you go back to the previous example, say you have this, right? So shirt ID, design and size. Okay, so what you could basically do is that you can actually split your table in such a way that shirt ID and size. So shirt ID and size, and shirt ID and design. So shirt ID and size, how you could do is that shirt ID XSL, everything into into different things. You can actually make it into different things. And so see here, so this is the one which is basically repeating. Okay, so remove the repeating group into a new entity. So we are actually repeating, so the repeating one is basically size, so we are actually taking the size out. Okay, and say just imagine that you're giving the name as a size info, and then give the new entity a name, then identify the primary key of the table. Say we are identifying size as the primary key. Now take the key from the first table. So what is it? Key from the first table, that is shirt ID. So you're actually keeping the shirt ID here. Now what you have to do is that label it as foreign key. So basically the shirt ID is actually a foreign key to this particular table, right? Now what you have to do, now you have a composite key, because you need both. You cannot just take shirt ID alone, or you cannot take size alone, because M's are repeating. So this exactly works like your composite entity. Okay, so when you look at here, now you have two different tables. Now you have this design also there, so you will keep it as a separate table, so that you have shirt ID as the primary key itself. So this is how you will actually expand your 1NF. So if you have a multi-valued attribute, this is the simple algorithm or procedure which you could follow in order to make a composite entity. Okay, and you can also have the rest of your tables in that. So this is what we have seen. So now when you look back to understand what is your 1NF, you should understand that you will be given with an unnormalized form. Okay, you will be given with an unnormalized table. So if you are given with an unnormalized table, the main issue, or the point which you have to keep in mind is that you can have this multi-valued attributes. So you need to remove this multi-valued attributes in the first NF. So after the applying, or say you can say that your database is in the first normal form, in that first normal form, you should not have any multi-valued attributes. You should have removed this multi-valued attributes by the end of the first normal form. So if you don't have any multi-valued attributes, then you could say that your table is in 1NF. Okay, hope it's clear for you. Now moving over to the second normal form. So in second normal form, our aim is that we need to convert the table from 1NF to 2NF. Okay, so what is basically this 2NF? Let's see, let's understand what is 2NF. What are we expecting to, or what expecting to do in the 2NF? So for your table to be in the 2NF, your table has to be in the 1NF. So that is the first rule which you have to follow. And the second one is that there should not be any partial dependency. So now the first thing which you have to understand is that what you meant by a partial dependency. Okay, say you have a customer table which is given to you, which is named as customer info, and say these are the various attributes which are there in your table. Say customer ID, store ID, customer name, store name. So when you look at this particular table, if you could see the store name is basically dependent on the store ID. Okay, it is not basically dependent on the customer ID. Instead, the store name is more closely related to store ID. So you could say that store name is having a partial dependency here upon the customer ID, right? So the customer info is not in second normal form. Okay, the store info table is basically, our relation is not in the second normal form, because you have certain non-key attributes which has got partial dependency upon the other attributes. Okay, so that's what you have to understand. And what do you mean by partial dependency? Here, if you could see, the primary key of this particular table is customer ID and store ID. Okay, so you have customer ID and store ID as the primary key, and the store name is actually partially dependent on the primary key. Okay, so it is not fully dependent on customer ID and store ID. Even, I mean, like, there is a redundant attribute customer ID when you consider the store name. Okay, so that is nothing but the partial dependency. Okay, so what we could do is that, yes, in normal forms, the normal solution for us is to split your tables, right? So if you have a table like this with the primary key, which is a composite key, okay, so why they are taking the composite key is that in the first normal form, basically you are splitting the table in such a way that you will have the tables with composite composite keys. Okay, because this is your composite entity. So the composite entity means you will have composite keys. So you are dealing with such tables. Say after the first NF, you got a table with the composite entity. So in that composite entity, or in that composite entity, that composite, when you consider the composite keys, there could be another non-key attributes also. So some of the non-key attributes are only partially dependent upon your primary key. Then what you could do. So that is what we are going to see in the second normal form. So in the second normal form, your table has to be in the first normal form. Yes, it is in the first normal form. Now we need to see whether is there any partial dependency. Yes, the store name is actually partially dependent upon this combination of the key, because the store name is only dependent on store ID and not on the customer ID. So there is a partial dependency. So this table currently in its form currently it is not in the second normal form. Now what can we do for it? So what we could do is that our normal aim is we can split the table. So how can we split the table? Yes, we can split the table into two different tables, one as a customer data and the other one as a store data. Okay, so what we will do is that we will split the table as customer ID and customer name, and store ID and store name, and we will keep the customer ID as the primary key for this table and store ID as the primary key for this particular table, right? So now for a particular table to be in the 2NF, it has to meet the requirements of the 1NF, and the other one is that all non-key columns are functionally dependent on the entire primary key. Okay, so that means that here when you look at the customer name, it is completely or fully functionally dependent on customer ID. If you look at store name, it is fully functionally dependent on store ID. Okay, but in the earlier cases, basically the store name was partially only dependent on this, because the primary key was the combination, right? Because it's a composite entity, it's a composite table, right, with the composite key, right, as the combination of store ID and customer ID. So this was only partially dependent. So it was not conforming to the standard for 2NF. So what we have done is that we have split the table into two different tables, so that now the customer name, which is the non-key column or non-key attribute, is fully functionally dependent on the primary key. The non-key column is fully functionally dependent on the primary key, which is store ID here, right? So now when you look at this particular, say this is another example. So just imagine that here, sometimes, you will be given with the schema. You'll be given with the schema and you will be given with the functional dependencies. Say here the functional dependencies which is given as, how can you identify the functional dependencies? SSN, comma, P number. The combination of these two is functionally dependent on hours. Then this one alone, SSN, is functionally dependent on ename. Then the other one is the combination, like the P number. The P number is functionally dependent on the combination of non-keys, P name and P location. So these are the three different things. So you have this SSN, P number on hours, SSN on E name, and P number, and P number is basically on P name and P location. So here when you look at this, this hours, it has to know that for which employee and which project he is actually working. So it's fully functionally dependent. And E name, it is fully functionally dependent on SSN. And if you look at the project name and the location, it's fully functionally dependent on the P number. So this this conforms to, or this abides the rule which has to be followed in 2NF. So this table, now when we split this particular table, this is basically in second normal form. Okay, so in the second normal form, it has to be in the 1NF, and all non-key columns are functionally dependent on the entire primary key, and there should not be any partial dependency. Okay, so now in order to follow a simple algorithmic way of doing things, what we have to keep in mind is that in the first normal form, yes, we were trying to avoid all the multi-valued attributes, right? So here in the second normal form, we are actually going to eliminate all the non-partial key dependencies. We should make sure that there is no partial key dependency, right? So for that, what you have to do is that first you have to identify a composite key, a key with more than one attribute, right? So normally you will get that, if you are actually trying to clear a multi-valued attribute, and in the first normal form, normally you will get a composite key. So now after that, what you have to do is that you need to make sure that look for the attributes which rely only on one of the keys. Now your primary key is a combination, but one of the non-key attribute is dependent only on one of the primary key, not both. Okay, now remove these attributes and place it in a new entity, and then keep the copy of the key which are dependent on in that particular table. And since the new key is primary key in the new entity, make it as a foreign key. So basically, obviously it is a foreign key, then you will get basically two different attributes. So when you look at this thing again, so you have a table which is given to you, and this is the table which is given to you, which has got both. It's a combination. So now what you have done is that you have basically look for the attributes which relies upon one. So now you have actually store the store name which is dependent on only one. So you're splitting it, then identify the most appropriate primary key for it, and make sure that your table is split and there is no partial dependency between the items, right? So this is another example is just given to you. Say, just imagine that your primary key is student. So this primary key, normally in the primary key, or it is also called as a candidate key, because the candidate keys are eligible ones for your primary keys, right? So say your student and subject. Say student and subject are the this combination is the primary key. So this is your composite key. Okay, now when you look at this particular table, okay, age is basically dependent only on the student, not on basically the subject, right? So there is so student and subject is the combination. This combination is the primary key, and now age is actually dependent only on the student and not exactly on subject. So age has got a partial dependency upon the primary key, right? Upon this particular primary key. So what you have to do, so when you get a table like this, there is a multi-valued attribute also. So what you could do is that you will change it into all this is now in the 1NF. So once you look at it, there is a 2NF issue or partial dependency issue which is there in the table. So if you have that issue, what you have to do, you have to divide that particular table into two different tables, right? So how will you do is that you will keep it as student age, okay, student and age. So you are keeping the age and you are keeping the primary key along with it, and then you are actually splitting it into subject, and you are keeping the most appropriate primary key in that. Okay, so when you look at it, so you are basically, so look for the entities which rely on one of the keys, remove the attributes and place them. And since the new key is the primary key in the new entity, make it as a foreign key. So here, in order to say this is your subject, so in order to have a relationship between those tables, you are actually student as a foreign key here. So student is basically the foreign key here. And so when you look at it, student and subject together is here. This is actually the composite key, right? So this is the PFK, and this is the FK, which will become the PFK. And so you have to consider both of them together. So here it is, student and each together, right? So Adam 15, Alex 14, Stuart 16. Here it is actually a combination of these two. So like that, you are actually making your table in this 2NF. Okay. So now this is another example. So here it's actually you're given with the student instructor. So it's kind of student instructor means it's kind of a composite key. Okay, so composite entity, it's a composite entity which is a combination of both student table and the instructor table. So when you look at location, branch, department, batch, section, role, all these things are a combination of your primary key. So your primary key has got a lot of combinations, but when you look at the name, it is basically part of only it's partially dependent. And when you look at the class advisor, it is partially dependent. When you look at the HOD, it is partially dependent. So what you could do is that, say, a location, branch, department, and HOD. It could be one of your combinations. And then you can actually make it in the location, branch, department, then branch, section, roll number. So if you keep the roll number and the name, it is about the student information. And section with the class advisor, you could say that the advisor information. So you are actually splitting the table into 3 different tables where there are no partial dependencies. So HOD is basically, you need all the 3 information. So it is fully functionally dependent. Now when you look at the class advisor, it is fully functionally dependent upon this complete primary key. When you look at this roll number and name, like the name, it is fully functionally dependent upon, because you need to know the location of the student, the branch of the student, the department of the student, the batch, everything is fully functionally dependent. So you are actually eliminating all the partial dependencies which could be possible in this particular table, right? So you should understand that initially you'll be given with a particular unnormalized table. You need to look for the multi-valued attributes. And so in the first normal form, you're removing all the multi-valued attributes. And in the second normal form, you're actually removing all the partial dependencies. Now moving over to the third normal form, it's kind of the simplest one. So you have a 2NF and you have to convert it into 3NF. That is how you're going to do. So if a table is in 2NF, then you need to make sure that the table has satisfied all the properties which has to be satisfied by 2NF, and there is no transitive functional dependencies between non-key attributes. So you know what is non-key. So other than the primary key, what all are the attributes which are there? They are called as a non-key attributes. So, and what do you mean by transitive dependency? It is very easy. Say one of your attribute is A is functionally dependent on B, and B is functionally dependent on C. Okay, then you could say that A is functionally dependent on C. So it's kind of a ternary rule, or which comes in place. So these two are related. So that means that A is to C is also related. That's a rule. Okay, so an attribute that does not occur in any candidate key is called non-prime attribute. Okay, so let's see what it is. Don't get confused. So in the table, you need to make sure that it's in 2NF, and it also requires there is no functional dependency between non-key attributes. Like between the non-key attributes, you're not worried about the primary key. About the other attributes, there should not be any dependencies. Okay, say you're given with this particular table, like you have book ID, genre ID, genre type, and price. So these are the information which is given to you. So when you look at this particular ID, say just imagine that book ID is the primary key of this particular table. So when book ID is the primary key of this particular table, then you are taking the non-key attributes. So the non-key attributes are genre ID, genre type, price, right? But when you look at this, the non-key attributes, genre ID and genre type is having some dependency. So how can you actually make sure that there is a dependency? So for that, you can actually follow this rule. Say just imagine that book ID is functionally dependent upon genre ID, right? And then genre ID is functionally dependent on genre type. Okay, then you could say that there is a functional dependency between book ID and genre type. You getting it? So that is nothing but the transitive dependency. So there exists some kind of a transitive dependency between this ID between this attributes which are there in the table. Okay, so now what you have to do is that you need to make your table. So our solution is always splitting the table, splitting the relation, or splitting your entities into multiple tables. So what you could do is that you are actually splitting the table into book ID, genre ID, and price, right? So this genre ID will become a foreign key to this particular table, and then genre ID and genre type. So this is the the non-key dependencies which you have basically found. Okay, you have, but that you have actually put it into a separate table, right? So what you have to do is that you need to identify all the entities, and you are looking over to the non-key attributes. Say in this particular case, you were looking over to the non-key attributes genre ID and the genre type. Yes, and if there is which rely upon each other, yes, they rely upon each other. And then what you have to do is that you have to put them into a new entity. You're putting them into a new entity. Now give the new entity a primary key. Yes, we are giving the primary key as a genre ID, and link the old table and the new table with a foreign key. Okay, so here when you are how to link between them is that you are putting this genre ID in the table book, so that both of the tables are basically related. So this genre ID will be a foreign key here, book ID is a primary key here, right? And here this is the primary key. So this is exactly what basically they are actually asking you to do. This is nothing but the third normal form. So in the third normal form, basically we are trying to avoid the transitive dependencies in the so from the second normal form, when we make sure that when the table is in the third normal form, it will basically remove all the transitive dependencies. So we have a database, we have designed a database. Our aim is to make sure that there is no inconsistencies in the data, there is no redundancy on your data, I mean like the data in the database, and your data integrity has to be maintained. Even if you do any of your insertion, updation, or deletion, anything onto your table, this data integrity has to be has to be maintained. So how can you do that? As you can do that with the help of normalization. So what do you mean by normalization? It's just a simple process which help you to make sure that it's a process which help you to eliminate the redundancy, inconsistency, and maintains the data integrity of your data in the database, right? So how can you do that? Yes, you can do that with the help of the first normal form, second normal form, third normal form, and so on and so forth, right? So what do you mean by the first normal form? Yes, when you have an unnormalized data which has got any multi-valued attributes, yes, by the end of your first normal form, you will remove that multi-valued attributes by creating a composite entity. And now what will you do in the second normal form? Yes, in the second normal form, you're trying to remove any partial dependencies. Partial dependencies means the non-key attributes has got a partial dependency upon your primary key, right? Then you are actually splitting the table into two different tables and making the different primary keys. You're giving different primary key to that particular table and eliminating the partial dependencies. Now what you have to do is that now you need to remove the transitive dependencies. That means that you are simply looking over to the non-key attributes. You're not worried about the primary key attributes. You're looking over to the rest of the attributes in there. And in between the rest of the attributes, if you could find out any relation, keep it into a separate table, give it something, and then give a primary key to that particular table, and keep an you need to relate both the tables by keeping the the primary key of this particular table as a primary key of your original table by making it as a foreign key. So that is nothing but the three different steps in the normalization. Okay, so now say this is actually an example for you for the third normal form. Say just imagine that student ID is a primary key, and you're actually given with this particular data. Okay, so when you're given with this particular data, you will understand that. So these are the non-key attributes. In the non-key attributes, student name is actually dependent, so you don't have any issues with the student name. But when you look at this DOB, street number, city, and state, it is actually dependent upon the SIP. SIP will give you all this information, right? So now you know that you could see there is some relationship between this particular data with the SIP, right? So now what will you do? You will keep all this information as a separate table. So these are the non-key attributes, and there are some relationship between the non-key attributes itself. So you're keeping it as a separate table, right? So you're keeping it as a separate table, and then in order to make sure these two tables are related to each other, what are you doing? You're actually keeping the SIP onto this particular table. You're getting it? So you're actually keeping, this is actually zip is a foreign key to the student entity, and SIP could be your, or in the street number could be your what is it, primary key for this particular table. So this is how it works. So now your table is in the 3NF. Okay, so if you have a normalized file structure, just make sure that you're removing all these anomalies, and you're actually getting a table with a more appropriate format with less inconsistencies and say you have removed the redundancies, and and the data, the integrity of the data integrity is actually maintained in your database. So this is all about your normalization. So in the next lesson we will try to take a real-time example like this, like say order date, etc. So you're given with a data base like that, I mean like an entity like this. So how will you actually say, if I'm giving you a data, real-time data like this, then how can you actually apply this different normal forms and make your data, your complete data in the database normalized? That is what we are going to see in the next class. So stay tuned, and hope you will go through this normalization process again, and try to understand with a lot of doing extra exercises and everything. So if you have any doubts or anything like that, always get back to me. Thank you so much. Thanks a lot.